It's my pleasure to moderate this session. We are honored to invite Mr. Edward Fox to give us a keynote speech. Now I would like to introduce our distinguished keynote speaker. His topic is applications of big data analysis for the worldwide collection of ETDs. Mr. Edward Fox served as Executive Director and the Chairman of the Board of NDLTD, having worked with ETD since 1987. He is a Fellow of ACM and a Fellow of IEEE at Virginia Tech, where he had taught since 1983. He is Professor of Computer Science and directs the Digital Library Research Laboratory, having helped found the digital library community in the earlier 1990s. He also is affiliated with the Center of Austin Research, the Center for Human-Computer Interaction, the Discovery Analytics Center, and the Global Change Center. He is a member of ACM Publication Board and of the IEEE Thesaurus Board and on numerous editorial board. An active researcher, he had been co-principal investigator on 125 funded projects. Google Scholar assigned him an H index of 58 based on over 17,000 citations. He has authored more than 415 books, book chapter, journal, conference, workshop publications, and given over 480 other presentations. He served as chair of the ACM Special Interest Group on Information Retrieval and the chair of IEEE Technical Committee on Digital Libraries. Now, please join me in welcoming our first keynote speaker, Mr. Edward Fox, with a big round of applause.
Ladies and gentlemen, let's welcome Dr. Edward Allen Fox again.
So I'm teaching a course this semester called Big Data Text Summarization. And I thought having the title Big Data might be interesting to some of the people here. And one of the projects in this class is involving about 15 students who are studying how to make ETDs more accessible using advanced machine learning. So I want to introduce you to some concepts about this and see where we stand. So the talk has 4 parts: a brief introduction to set the stage, a bit about big data, and then kind of broadening the perspective, and then the machine learning part is the last one about the analysis aspects to this. So first of all, I want to give some acknowledgments as part of the introduction, talk about some of the projects and research we're doing now and some of the aspects of big data. So first of all, it's really important in any kind of scholarly activity to understand how many people have contributed to what we're talking about. So I've been fortunate to have had wonderful mentors, to have many different agencies sponsoring the research that is being discussed today, many students, colleagues, co-workers, staff who've been involved, and I give a short list of some of the people who work with me over the years and have led to the work that is discussed here. So they're the ones who do the work. I'm just trying to help explain it. So there are 4 dissertations that have come about. Since we're all about ETDs, I try to highlight the contributions of research students and the effects they have on the world. And I've been really blessed to work with 4 of these students, as well as many others, but these relate to the discussions we're having today. So the first one pursued education and building portals, and he developed methods for classifying things automatically. So many of you are familiar with cataloging, so classification can be done now with the help of computer systems. Sung-hee Park worked on taking the references that you find in dissertations and other works and understanding them, analyzing them, and putting them into a database so we can understand who the names of the authors are and the journals and so on. Ryan Richardson looked at electronic dissertations and he said, how can we help people understand them more easily in different languages? So he built a concept map to show the structure and the content of a dissertation, and then he translated it to another language so that people could easily find and discover this in different works. And just recently, Xuan Zhang has just finished his dissertation. I approved it a few days ago. And his work has to do with machine learning and summarization, and I'll talk a bit more specifically about that. My undergraduate advisor at MIT was J.C.R. Licklider, a very famous person who gave some of the early money from when he was working at DARPA to fund the internet. He wrote a book in 1965 that has inspired me ever since. This book was about libraries of the future. And part of the vision he gave us in this book was that we would have a network of libraries all around the world reaching down to communities involving cities, states, nations, and ultimately the world. So this is a wonderful vision, and he also gave us some inspirational challenges. How can we have a theory that will explain how to build all these things? The work that I'll be discussing here at current is also being funded by a number of different groups. The Institute for Museum and Library Studies in the US is one of the agencies that's supporting building cyber infrastructure and promoting education and spreading that. And I've also been fortunate to be supported through a number of projects from the National Science Foundation. The first one is very germane now because this project is studying hurricanes and typhoons and what they do to our transportation and to our power. So we're trying to understand all of that. And then the last one on this list is another piece of big data where we've collected over 2 billion tweets. Whenever there's some important event in the world, we try to collect the tweets and the web pages so we can understand what's going on in the world around us. So the first of these IMLS projects is posed the question, what should libraries do in terms of their computing infrastructure? Should they have big high-performance computing? Should they build a network of computers linked together? Should they have them all clustered together into a big hub to carry out things? And so we've done a number of studies of different things that libraries do to see which of these kinds of infrastructure gives the best performance. So that's kind of an introduction to kind of set the stage of what's going on. Now you've heard the term big data. Many people view it as defined by 3 or 4 things, and I think the 3 that are most important in our context, because certainly ETDs cover big data, is the variety. So ETDs are in all different languages, they're in all different styles, they're in all different disciplines, they have different formats, they're at different levels from bachelor's to master's to doctoral. And so this variety poses challenges. How do we manage all of that? The second thing is the velocity. They're being produced all over the world by students doing research constantly. And so they keep coming out. And for those of you who are in universities and libraries, you know at the graduation time, there's this enormous mass that comes in at the same time of people graduating and wanting to get approved and so on. There's also the need of people to use the research from graduate students all over the world. And as we heard, 1 million accesses here to the Taiwan information system relates to dissertations. And researchers want things urgently, so this velocity is important. And the last one is the volume. In the union catalog that's run by the NDLTD, we heard about 1/5 of that comes from Taiwan. So we have about 5.5 million entries that point to many files. So a large amount of information. And it's not just text. There's videos, there's photographs, there's images of other kinds, there's simulations, there's data sets. And so this is an enormous amount of data. How can we manage that, discover it, and help people get access to that? That's one of the challenges that we face. So some of you have probably familiar with the term high-performance computing, and probably also with very fast computer networks. That's what most agencies in governments and institutions think of as the high end of computing. But what is inside those computer systems and what travels over the network, that's the content. And so this community represents the third dimension of this, the content dimension, which gives importance and meaning to the fact that we have fast computers and fast networks. So let's remember that we're really important in this big picture. Here's one of the early dissertations that came out of Virginia Tech, actually a master's thesis. And this had to do with the design of Turkish coffee houses. So coffee and tea, I know, are very important in this and other parts of the world. And you can see some of the photographs, and there were pictures and images and so on from inside, and that was part of what was being conveyed. That adds enormously to the size of the work and also to the interest of what's going on. It makes it more artistic as well. So when you think about the content that's available electronically and is available through theses and dissertations, not just the paper, the PDF files, but the data sets and the explanations and the simulations and the interactive visualizations, you can see that there are many, many kinds of content. And so one of our challenges in terms of the volume is to handle this enormous variety and size and scale. So we have geographic information systems with aerial photographs. We have software simulations of enormous scale trying to predict the spread of disease. We have genomic information from individuals and many other species. We have all the imagery that's part of the medical world. So this is an enormous amount of information to handle. How can we manage this well when we're trying to deal with theses and dissertations? That's one of our big challenges. So let's broaden the perspective and kind of set this into some theoretical framework. I mentioned before about J.C.R. Licklider, about his vision of how can we have a theory that explains our libraries, our digital libraries, our information systems. So inspired by his work, we've tried to explore this in detail, and I want to set the stage a little bit to put this in perspective. In 1997, there was a workshop on the social aspects of digital libraries. And we came up with this kind of crude picture which explains the life cycle. And in Asia, there's an understanding of things that travel through many cycles of life. So I redrew this picture into one that's a little bit easier to read and follow. And if you think about an ETD, it kind of is at the top of the picture there. There's a student, an author working with a committee of people creating some work. So this is the act of creation. And then it goes through a number of different stages as it moves around the cycle. It gets organized, it gets indexed, it's stored, it's made searchable, it's sent over networks, people find it, they use it, and then they build new research on the ones that they found for that. So what's really important is that our theses and dissertations be widely spread around the world so other people can benefit from them and make new contributions and knowledge can advance from this. So this is the information life cycle. Now, for that to work well, we have to do it in a good way. We have to have high quality. So we can look at the picture from the center out, have these sort of four big phases, and then around that we have another circle here, which talks about more of the details. And then the circle on the outside has to do with the quality. This is something we don't always remember. Libraries have become helpers of publishing and of access. And we have to make sure as we work with ETD programs that we don't just collect PDF files, we help people communicate, and we make sure we have the right metadata, we have the things being searchable, we have everything being accurate and complete, and it's timely, and people know it's pertinent to their interests, and that we have it searchable in a way that it's relevant to people's questions. So these are kind of attributes that libraries should enforce in these systems, and we should make sure throughout the life cycle that we support these so that we get the best possible results, the best practices. So to put this in a perspective, to make it really simple, and sometimes I do the 5 elements with this as well, but here I'm just going to talk about 5 layers of an information system of a digital library. And I think we all work with information systems, but they kind of are a mess, and we don't really have an underlying theory for this. So inspired by J.C.R. Licklider, we came up with this 5-layer approach. The most important one, of course, is the top one. That's the people, the societies. And people now know about social networks and so on. So this top layer is not just individuals, but groups and institutions and whole societies. And they want to do things. They carry out certain scenarios. They carry out tasks. They want to accomplish certain things. They do that in a space. We're here in a 3-dimensional space in the room. We travel around the world in space in some sense. And then the mathematicians give us vector spaces, probability spaces. So spaces are important to give us identity of things and what operations work with them. But then we have to organize it, and that's where the structures come in. And then we have the flow and the continuity and the video and the audio and the series of characters that make up a word in a book and so on. So streams are also a key part. And when we build a system, we can think of it from these 5 layers and how they fit together. We have 4 books and many articles and dissertations about this whole thing to explain it in more detail, but that's kind of a high-level perspective. And we can then use that to define that we're trying to build information, satisfy the information needs of people through services that are usable and present them in good ways and communicate effectively. So this is another way to think of those 5 layers. Now, if we take that kind of perspective, we can think of all the services that libraries try to perform to make these things work. And this is a taxonomy of a broad set of services, some of which we do in our systems, but more of which we need to do and more of which we need to do even better. And I think it's good to sort of divide this up into the first side, the 3 things on the left are all about the infrastructure. We have to build things so we can do what's on the right side, make people happy, help them be satisfied. So most people think of the right side, that's the services that are outward facing to the users. But for all that to work, as the people who work in libraries and archives know, you have to do many things to prepare for that. So we have to build our repositories or our libraries, and that's sort of the first two things in this. And the first part of that is creating the work, which is part of what we do with ETDs, getting students and faculty to engage in that. And then we have to make sure we preserve it so it goes on into the future. So there's lots of pieces to that, and each of companies and individuals maybe focus on some of those different parts to this. This is the creational aspect. And you see there's many parts. We talk about harvesting and other things. On the preservational side, sometimes we convert things or we translate them. So there are many parts to that. But then we also want to add value. So cataloging is doing classifying. With computers, we can do clustering to help with that process. We do indexing. We do rating of things. We do peer reviewing. All of these things add value to the original works, and they're crucial for things to be successful. So that's all sort of the infrastructure to make everything accessible to the people and satisfy their different needs. So most people think of searching and some browsing. We also know about recommending. But we do more and more visualizing. So if we really want to build a comprehensive system to support people's needs, we have to do all of this. So I want to make it clear that there's a long way to go for us to make this happen for all the ETDs in the world and to do it well and with high quality. We sort of began to sort of distribute these things by just looking at the metadata. And the Open Archives Initiative, which began, I think, in 1997, 1999 got going even more strongly, was to share metadata. So the notion here is to harvest from reference libraries, from publishers, from ePrint archives, from museums, and then make the contributions, to make the contributions from all the different data providers. So we may have a local university and another local university that contributes to a national university that contributes to a world collection like our Union Catalog. And these things then can go into provide a lot of different kinds of services, like the list that we showed before. So going back to this notion of quality and how important it is, we can think of what we have in terms of what are the concepts or aspects of a digital library. We have the individual object, the thesis. We have its metadata. We have the collection of ETDs at a particular university. We have the catalog that explains that. It fits into a repository, and it provides a number of services. And again, each of those has its own aspects of quality that we can make sure we're enforcing. As we build these things, we don't just build them, we want to make sure that they do a good job. And these are the dimensions on which we can evaluate those. Okay, so now that you've had a kind of broad perspective, I want to get more into the big data analysis, which is what most people are excited about. So the first point here is that we did a survey of people to see if it would be good to take theses and dissertations and do big data work with them. And we asked all kinds of experts about this, and it turned out that there was very strong support for doing this. So that's exciting that the people who are expert in all the text analysis and linguistics and so on were interested in this. The second thing is that there are some companies, there's one in Oxford, England called Content Mine that works with this. The third thing is we have to identify and support the services, and there are three kinds of things that are important in this. One of them is making the work accessible, but the others that we can do with machine learning and deep learning are to classify things well and to create summaries. So let's talk more specifically about those. So, okay, here's this first thing. The survey was done of many different researchers in all these different areas. You can see lots of different areas are interested in the kind of content that we work with. We had 18 respondents, and they were interested in the data that we have in the ETDs, including the citations, the references, the figures, the tables. They were interested in having software that would extract knowledge out of these works, and they were interested in answering research questions, such as how do we summarize long documents. So these are some of the responses that we had. 74% said mining the ETDs would be valuable for their own research community. 53% said they would be highly likely to use an infrastructure that would support analysis of ETDs. And 68% said that they thought new collaborations and initiatives would emerge from doing this kind of work. So here's more about Content Mine. Some of you who have been to some of the ETD conferences have met Peter Murray Rust. He's a principal for this, chemist background. And the idea is, and these are the kinds of projects that they do, is they collect things, they convert them, they extract things from them, such as chemical formulas and equations and so on, and then they create dictionaries and reports and analyses for these. This is important because there's lots of work around that we'd like to connect with. So just to show there's a corporate interest, and remember you saw this picture before, I added to this picture a bunch of arrows. Some of the things we've done so far have to do with the harvesting, the classifying, the extracting, the indexing, the searching, the recommending, and the browsing. But you see there's lots more things we still have work to do on to expand this more broadly. So one doctoral student, Venkat Srinivasan from India, has been studying classification. So this is a traditional big data, text mining, machine learning kind of problem. So the question is, how do we find a dissertation by browsing in terms of its topics? So he said, let's pick a system like the Library of Congress category system. It could have been another system, but he chose that one. And so you begin with this tree structure of all the different categories in the category system. Now we need to understand what each of those categories mean. And so one of the things he did was he went and used those terms to search and find what documents relate to each of those entries. And there are more than 1,000 categories in the Library of Congress system. It's a very complicated, detailed system. So we have to be able to know what it's about, each of those categories, so we can figure out which ETD should be in which category. So that's the problem. We want to take every ETD and assign it to the right category in the category system. Now the advantage of computing and of our automated systems is we don't have to pick one place. If you're in a library, the book goes in one shelf someplace, but not somewhere else. But many ETDs cover many different categories, many different topics. So here we have the luxury of putting the same ETD in multiple places. So we want to go through this big Library of Congress category system and figure out how to do that. And so we teach the computer, we build what are called training sets. We build a software system called a classifier. We apply it to the ETD collection, and that produces the ETDs with assigned categories. And so now we can browse. We can go through the Library of Congress category system, find the entry we were interested in, and then find all the ETDs that fit into that category. So this is his research, his doctoral research in this. And he's almost finished, I think. The second problem is many ETDs have an abstract or a summary. And that abstract or summary is for the entire work. It's written by the author. Now, many theses and dissertations today have chapters that are on different topics because people do interdisciplinary work. They cover this, they do one method here, they apply it to this data set, and so each chapter in its own right is interesting. But we can't find the chapters, and we might not even find the right works, if we only look at the abstract for the whole thing. So wouldn't it be nice if we had an abstract for every chapter of every thesis or dissertation? So that's the problem that we're interested in solving. And this is a difficult thing. We can't get the authors to go back and do it because they finished, they've graduated. So we want to have a machine to do this automatically. And so I have 3 teams of students this semester working on this problem as a graduate class problem. And they're trying to figure out ways to automatically do this kind of thing. So we have some prior work. I mentioned Ryan Richardson's work to do this with concept maps and translate them to different languages. This is the course that I just mentioned. And there's also a dissertation just finished by a student who's been looking at this. So let me give you some pictures, and this may not make any sense at all, but just for those of you who are technically interested into this. There now are some methods to do this kind of work, and there's an algorithm called TextSum that does a neural network system to take something that you see down here and represent it and then be able to generate a summary. Another current method is called pointer generator networks. And so here we see the source text, the chapter. We go through all this kind of processing of a big neural network, which we've trained, and then we come out with a summary on this end. So Xuan Zhang's dissertation, just finished, has been doing very similar kind of works, and he's built some more sophisticated neural network-based summarization techniques. This is one that looks at and for those of you who are in the this is RNN, CNN, encoder, decoder with attention mechanism. And he builds some kind of context vector and then moves this over and then does the summarizing in a decoder. And so we are moving forward, as you can see, on a pilot project starting initially with 30,000 theses and dissertations from Virginia Tech, segmenting them, trying to extract all the interesting content, and produce summaries and other kinds of analysis. So our goal is to create an infrastructure that we can give to the National Central Library of Taiwan and many other groups around the world so they can run this on their own content and be able to have better access to this kind of information. So these are the things I talked about, and I don't know if we have time for comments and discussions, but I want to thank all of you, and I hope that it was not too crazy, but this is the kind of research that I'm involved in, and it's wonderful that hopefully this can lead to better systems for the future. So thank you.